Let's solve problem number 1. Mercury flows in a 100 mm diameter pipe at 20 degrees Celsius with a kinematic viscosity equal to 1.15 times 10 raised to negative 7 square meters per second with a flow of 0.8 liters per second. Determine if the flow is laminar or turbulent. So the kinematic viscosity of mercury at 20 degrees Celsius is equal to 1.15 times 10 raised to negative 7 square meters per second. So this is the kinematic viscosity. And the Reynolds number, in terms of kinematic viscosity, is equal to velocity times diameter divided by the kinematic viscosity. Yan. So to determine whether the flow is laminar or turbulent, we need to know the Reynolds number. So if it's less than 2,000, and that is laminar. If it's greater than 2,000, and that is turbulent. Okay, so first we need to know the velocity. Since it is in terms of velocity, we need to solve the velocity given yung discharge. So we know that velocity is equal to Q divided by the cross-sectional area. It's equivalent to, so we have, what is the velocity? We have, 0.08 liters per second. How many cube i-convert natin na lang sa cubic meters per second so that the resulting value would be in meters per second for the velocity. So we have, so this 0.8 liters per second. Gawin natin cubic meters per second. So we have, in 1 cubic meter, we have 1,000 liters divided by, so we're left with cubic meters per second, divided by the cross-sectional area, which is pi, times the diameter is, where's the diameter? 100 mm. It is 0.1 meters. 0.1 squared all over 4, so that the resulting velocity is equal to 0.1019 meters per second, which is very slow, but let's see if it's laminar or turbulent. Then we can now solve for the Reynolds number, that is equivalent to, so we have 0.1019 meters per second times the diameter, which is 0.1 of a meter, divided by the kinematic viscosity, 1.15 times 10 raised to negative 7 meters square per second. So cancel yung meter square, tapos yung second. So we have a dimensionless value, which is equal to 88,608.96. No, sorry. Is 696. Okay. So this is obviously less than 2,000, so therefore this is turbulent flow. So the flow is turbulent kahit na medyo mabagal yung velocity, turbulent pa rin, So usually yung flow dun sa gripo, sa bahay, sa water system natin, usually those are turbulent flow. Okay, so that is number 1. Okay, number 2. What is the Reynolds number for a flow of oil with a specific gravity of 0.8 and absolute viscosity 0.002 pound second per square foot, or that is actually pound per square foot second, whatever, in a 6-inch diameter pipe at flow rate of 10 cubic feet per second. So since we are given yung absolute viscosity, then we need to use the formula for Reynolds number in terms of absolute viscosity. V times density divided by the absolute viscosity. Okay, so first we need to solve for the velocity, the density also. Diameter is given. Okay, so solve for the velocity, that is equal to Q all over A. So the discharge is given at 10 cubic feet per second. So we have 10 divided by the cross-sectional area given the diameter, that's pi, times, convert natin sa feet, so that is, there are 12 inches in 1 foot, so we have 0.5 feet squared all over 4. So the velocity is equal to 50.9296 feet per second. Then we solve for the Reynolds number using the formula in terms of absolute viscosity. So that is equivalent to, so we have solved for the velocity already. We have 50.9296 feet per second times 0.5 feet as diameter. And then we have the density. So we have 62. Since given naman yung specific gravity, okay, so density, i-multiply lang natin to sa unit weight ng water, that would be the unit weight of oil, and we divide it by the gravity to convert it to an equivalent value in density. So we have 62.4 times 0.8, that is in pounds per cubic foot. This is the unit weight. Then we remove the effect of gravity para maging density yung value. So we have 32.2 divided by 32.2 feet per second square. And then we divide it by 0.002 pounds second per square foot. So the resulting value, so if you try to look into the dimension or the units, cancel lahat ito, ano? Cancel lahat yung mga yan. And then so we have a unitless quantity that is 19,739.147. Okay, that's the Reynolds number, which means that the flow is still turbulent flow. Okay, so that is number 2. Okay, so that's the Reynolds number. Anyway, the problem is not asking us to classify whether the flow is laminar or turbulent, but the flow is turbulent obviously because it's greater than 2,000. So that's it, and then we will continue with the rest of the problems in another video.